Welcome all to the Vidyalakshmi YouTube channel. We have already learnt about dual nature of matter and radiation in our previous videos. In this video, we are going to learn about particle nature of light, failure of wave theory and the Broglies hypothesis. Okay. So, in this chapter, actually we are learning there are two forms, right? Radiation and matter. Radiation, which is actually a waveform, can also exhibit as a material. That's what we are learning in this. And also basic material for anything whatever we see is electron. So electron can also behave as a waveform. That's what we are going to see in this video. Okay, let's begin to the class. So firstly, particle nature of light. The very first property is in interaction of radiation with matter, radiation behaves as if it is made up of particles like photons. The meaning is like in photoelectric effect and its experiment we have seen, we'll have a metal surface and on it we have made light from different light sources to fall on it, right? Then on receiving the light, metal surface will be emitting the electrons, and for the photoelectric effect we have seen. Okay, so the first property tells us that in interaction of radiation with matter means whenever light source radiation is falling on matter, a metallic plate, radiation behaves as if it is made up of particles like photons, that is waveform. Light is made up of small quanta of particles known as photons. Okay, so that is the first property. Then the second property tells us that the relation between energy of each photon. Okay, energy of each photon is E is equal to h nu. So where h is the Planck's constant and nu represents the frequency of the light whichever we are making to fall on the surface, on the metal surface. And based on that, momentum of any particle of that particular photon will be h nu by c. We know the relation here. Okay, so here we know the relation between frequency, speed and wavelength of any light, right? So E is equal to h nu is the energy of the photon given by Planck's quantum theory, and then we know momentum for any wave will be equal to energy by speed of light. Okay, energy by speed of light. So energy is h nu divided by speed of light. Okay, so that's why I have written momentum P is equal to h nu by c. And also we know that relation between speed, wavelength and frequency of any light to be lambda into nu. Okay, substituting this value of c in this equation, we find that momentum P is equal to h nu divided by lambda into nu. Okay, so nu and nu will get cancelled. We will be left with momentum to be equal to h by lambda. Okay, so that's what is being given in this equation. So this is the first property that is showing us that wave can also behave like a particle. So to be a particle, what are the basic characteristics? Momentum and mass, right? So here we are finding that photon which has got energy E is equal to h nu has got a momentum h by lambda. Then the second property is irrespective of the intensity of radiation, all the photons of a particular frequency or wavelength have the same energy and have same momentum. The meaning is irrespective of the intensity. We have to remember that. If you vary the increase or decrease the intensity but with the same frequency of light, okay, with the same frequency of light and wavelength of the light, then all the photons present in that light source will have same energy h nu and same momentum h by lambda. So this we have seen from the effect of intensity and effect of potential of the electrons whenever they are emitting out of the metal surface, right? So we have seen the emitted electrons does not depend upon the intensity, whereas it is depending upon the frequency. I hope you will remember the graph. We had the second effect of photoelectric current with respect to potential. Okay, so when you have an intensity light, then as you increase in x-axis you will have potential, in y-axis you have current, photocurrent. Okay, as you increase the potential positive polarity, what happens? photoelectric current increases, but after a certain interval of time it attains the saturation current. And the reverse process is when you change the polarity, we observe that this current is decreasing, and then at some particular point, stopping potential, there is no emission of photoelectron at all. So this is what we have observed, right? So what happens when you increase in intensity, saturation current is increasing, but stopping potential we are getting at the same point as you increase intensity, okay? Intensity 1, intensity 2, like that. So what is the meaning of this? Stopping potential, we have already seen the relation between kinetic energy and stopping potential as E V naught, right? So the first intensity light has also got maximum kinetic energy which is equal to EV naught. Second intensity light has also got maximum kinetic energy which is equal to EV naught. So the meaning is all the photons falling on the metal surface, though you are increasing intensity, will possess the same amount of energy provided you are sending the same amount of frequency of a light, okay. So the emitted electron does not depend upon the intensity, it is irrespective of intensity, but it is depending upon the frequency. That's the meaning. So all the photons with the same frequency will have same energy and same momentum, okay. And the third point, by increasing the intensity of radiation of given frequency or wavelength on a metal surface, there is only increase in the number of photons emitted per second on that surface, okay. So saturation current is increasing here, right? You can see from the graph, as you increase the intensity, value of current is increasing, hence the saturation current value is increasing. So the meaning is number of photons falling on the metal surface has increased, so that it can eject out more number of electrons from the metal surface. That's the meaning here, okay. So this is the third property. Then moving on to the next property, all the photons emitted from a source of light travel through space with the same speed of light. So all the photons that are emitted from the source, they will have same speed only, okay. That's the next point, same speed of light. Then the next property is frequency of photon, which shows a definite energy, does not change when photon travels through different media. So meaning is whenever this light is passing through different media, we have different media, right? Air media, water, fluids, gas. Whenever this light is traveling through different media, its frequency doesn't change, okay. The next property is velocity of photon in different media is different, which is due to the change in wavelength, okay. So here comes the important thing, okay. C is equal to nu lambda. So speed of light does change in different medias, but frequency is remaining constant. Speed is changing, but frequency is remaining constant, does not change. Okay. So to make it balanced, wavelength has to be changing, okay. Frequency of the wave in different media will be changing, so that to obtain the same value, okay. And the next point, photons are not deflected by electric and magnetic fields, hence they are electrically neutral, okay. We have seen electric fields can deflect electrons and magnetic fields can deflect the charges, right. So similarly, but here photons are not getting deflected either by electric and magnetic fields, meaning is they are neutral, photons are neutral in general, okay. So the next property, so those are the properties. Next topic is failure of wave theory of light, and with this we can explain the photoelectric effect, okay. Okay, so our next concept is failure of wave theory of light to explain photoelectric effect. Meaning is with wave theory we are not able to explain the photoelectric effect. We will see the reason, okay. The first one, according to wave theory of light, the intensity of light is increased, so there will be increase in amplitude of waves, and hence energy carried waves will increase, okay. So the meaning here is, if you consider light as a waveform, when you are increasing intensity, what should happen? Energy supplied should get increased, so more amount of emission in the photoelectrons and photoelectric effect should have been observed when you increase intensity. But when we do it experimentally, we are not able to see when intensity is increasing, it is not, the energy value possessed by the photons is not directly proportional to the intensity. Number of photoelectrons emitted is increasing when you change the intensity, whereas electrons, energy possessed by the electrons, Ke max is equal to EV naught, we have seen, right. So that value remains same for all the various intensities, okay. So wave theory is not able to explain why when we increase intensity, Ke max, the stopping potential is coming same for all the photon electrons, okay. Then the second failure is, according to wave theory, by increasing the intensity of the incident wave of light, the energy increased and photoelectric emission will take place even if the frequency of the incident light is less than the threshold frequency. So according to wave theory, this is the thing, but threshold frequency we have seen, right, minimum frequency required for a electron to come out of the work function, right. So but this concept is not being able to explain by the wave theory, okay. So according to wave, energy, like light is moving in the form of a wave with energy, wave has energy in it, right. So as per that, even if the frequency of the light wave is lesser than the threshold frequency of the metal, it can eject out the electrons. So that's the concept as per wave theory, but minimum, if you supply energy minimum to threshold frequency, electrons can never come out of the metal surface. So this concept is not able to be explained by wave theory. Then the next thing is, when the wave of light falling on a metal surface, the energy of the wave of light will not go to a particular electron in metal surface, but will be distributed to all the electrons present in the illuminated portion of the metal surface, okay. So light is a waveform, it is moving, so light will, because it is a waveform, it will not go give its energy to particular electron. Throughout the metal surface, it will be sending its energy. That's what the concept given by wave theory. But we have seen, if it is like that, then throughout all the electrons should gain the energy from the light source, and then only all the electrons should eject out. But we are not able to see that, right. When light is falling on it, each electron is gaining energy and then electrons are getting emitted, okay. So this concept is also been like wave theory is not able to explain why only one particular electron is gaining energy from the photon and getting ejected, okay. This is the explanation for that, as a result of which electrons will take some time in accumulating the energy required for their emission from metal surface. But we have seen in the experimental part, as soon as the light source is falling, electrons are getting emitted, okay. It is an instantaneous process. So wave theory is not able to explain that thing, okay. Then based on this de Broglies hypothesis we have, okay. According to de Broglie, okay, so we have seen now like light can exhibit a waveform, right. So de Broglie's hypothesis is actually the reverse of it. Like he says, nature loves symmetry. If light can behave as a waveform, why not, if light can behave as a particle, why not a particle can behave as a waveform? That's what his de Broglie's hypothesis. So according to him, a moving material, okay, a moving material, a particle, sometimes act as a wave and also act as a particle. So a wave is associated with a moving particle, he says. So for example, electron. Then those kind of waves are called as matter wave or de Broglie's wave, whose wavelength is known as de Broglie's wavelength, and it is given by this relation, lambda is equal to h by mv. How we are getting that relation, we are going to see now, okay. So de Broglie's wavelength. According to Planck's quantum theory or particle theory of wave, okay, particle nature of light, we can tell E is equal to h nu. Let this be equation number 1, okay. As per Einstein's mass energy relation, we know E is equal to mc square. Okay, so we are going to equate these two relations. H nu will be equal to mc square. Okay, from here I wanted a formula of mass, so m can be written as h nu by c square. Okay, so from here I have got the equation for mass, h nu by c square. What is momentum? Linear momentum, we know it is the product of mass and velocity. M into velocity. Velocity I am going to call c. C is a speed of a light wave. Okay. So here, let this be equation number 4. Substitute 3 in 4. Okay. Instead of m, I am going to substitute this relation. And I will be getting P is equal to h nu by c square into c. So c square and 1 square and c will get cancelled. So h nu by c we will be getting as mass. We have seen that c is equal to lambda into frequency, right? C is equal to frequency into lambda. Then what happens? P will be equal to h nu by nu into lambda. Nu and nu will go off, so you will be left with P is equal to h by lambda. You can rearrange things, lambda will be equal to h by momentum. Okay, so this is known as de Broglie's wavelength. Wavelength of a moving particle will be equal to Planck's constant divided by its momentum. It can also be written as lambda is equal to h by mv. Okay, so in this relation, lambda represents wavelength of a moving particle, h is the Planck's constant, m is the mass of the particle, and v represents the velocity of the particle. So with this we can conclude that from this chapter, light can also behave as a particle because it is made up of small quantas, pockets of energy as photon, and each photon will be possessing an energy of E is equal to h nu. And based on that only, like, we have photoelectric effect and its relation in different graphical forms. Okay, so de Broglie is finally concluding that if light can behave as a particle, why not a particle can behave as a waveform? Okay, to be a waveform, its basic characteristics is wavelength and frequency, right? So he has calculated the wavelength for a moving particle. Okay, so in this lesson, finally we have got an idea that light can behave as a particle and a particle can also behave as a waveform. Okay. In our next class, we will continue with the numericals that is related to this chapter. Thank you all.